Now, still under operations on set, we want to take a look at complement of set. Now, for you to get complement of set, you must connect a particular set to the universal set. Don't forget that from the beginning of set, we talked about what we call the universal set. And we said the universal set is the set under which all the other sets are discussed, or it is the set under discussion, or the set under which all the rest are under discussion. Now, I've given you an example of the universal set in this illustration. The universal set is given as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the counting numbers from 1 to 10. So that is the universal set. Now, I've given you a subset A, where A is 4, 5, 6, 7, 8, 9. And what I'm going to do is to explain complement of set. Now, since A is a subset, I can only find a complement of A. The universal set is going to be compared to the subset. So we use the subset to compare the universal set. And that is when we say a complement of A. So to get complement of A, which is written as A with a strike on top, A strike here, then we are saying that the members in the universal set that cannot be found in the set A. I repeat, complement of set A are the members in the universal set that are not found in the set A. So let's compare the two and see. Compare set A to the universal set. I can see that 1 is in the universal set, it's not in A. So the first complement is 1. I can see 2 is in the universal set and it's not in the set A. So 2 is the next element. I can see 3 in the universal set, but 3 is not in set A. So 3 becomes the third element. Now, 4 is in the universal set, and then 4 is in the subset A. 5 is also in both sets. 6 is in both sets. 7 is in both sets. 8 in both sets. 9 is in both sets, but 10 is in the universal set, and 10 is not in the set A. So 10 is also part of the complement for the set A. So the elements or the members for the complement of A will be 1, 2, 3, and 10. I repeat, complement of A are the members in the universal set that are not in the set A. So compare the set A to the universal set. You realize that there are some members in the universal set, but they are not in the set A, and that is what we call complement of set A. So please take note of that. Now that you have understood it, let's illustrate it with a diagram. So this is a diagram illustration for complement of a set. Set A compared to the universal set. Now there are some sets in the universal set, they are not in A. So have you seen that I've shaded the universal set and I've not shaded A? But the complement of A has been shaded as part of the universal set. So that means those of them who are in the universal set but cannot be found in A are the complement of A. So this diagram speaks a lot about complement of a set. So don't forget, complement of a set is or are the members in that universal set that cannot be found in the set A. So complement of a set, you have to compare that set to the universal set before you can get the complement of that set. So the complement of a particular set, once again, will be the members in the universal set that are not in that particular set. So please understand the concept. At this stage, let us look at the properties or the characteristics or the behavior of complement of a particular set. Now the first character will be the complement of set A is the same set A. Let me explain it well. I want to look at the properties of a complement of a set. And what I'm saying is, if you take the complement of a set and its complement, then it is the same set. So I'm trying to say that, for example, set A. Let's take set A as an example. The complement of the set A's complement is still set A. So look at the universal set in my example here. I've given 1, 2, 3, 4, 5, 6 as the universal set. And I've given the set A as 1, 3, 5. So we are going to compare set A to a universal set in order to get the complement of set A. So the complement of set A will be the members in the universal set that are not in set A. Now let us compare. 1 is in the universal set, is in set A. So 1 is called a complement. 2 is in the universal set but not in set A. So 2 is the first complement of set A. 3 is in the universal set and still in A. So 3 is not part. 4 is in the universal set, it's not in set A. So 4 will be the second complement. 5 is in both sets. So 5 is not a complement. But 6 is in the universal set and it is not in set A. So 6 is a complement. So the complement of set A as compared to the universal set will be 2, 4, 6. So 2, 4, 6 are in the universal set, but they are not in set A. That is the meaning. Now look at the property. The property says that if you want to get the complement of this A complement, so the complement of A complement, this is A complement, and we want its complement. We are trying to say that it will still be the set A. Let us see whether it's true. Now, taking the complement of A complement, we get the A complement as 135. Have you seen it? So 135 is, now we are still comparing this to the universal set. 2 is here. So 1 is not here. So 1. 3 is not here. So 3. And 5 is not here. So 135 becomes the complement of A complement. So that means if you check A complement here and you compare it to the universal set, there are some members in the universal set that are not in this A complement, and that is 135. We check, you realize that's 135. Now, these 135 are the same members in the set A. So, which still is the set A? Or which is still the set A. So what we are trying to say that after you have gotten the complement of A complement also, it will still be the set A. That is what we are trying to say. So please keep this property. Take your time and understand it well. The second property for complement of a set will be, now the complement of the universal set is an empty set. And this is self-explanatory. The universal set actually shows a complement of another set. That is to say, if you want a complement of a set like A, you must compare the members in a set A to the universal set. So the explanation is, any member in a universal set that cannot be found in a set A is what we refer to as a complement of set A. So if you want to find a complement of the universal set, it is not possible because it is the same set we are comparing the others to. So the complement of the universal set becomes an empty set. That is a null set. There's nothing like that. So we are just trying to say that the complement of a universal set, which is universal set complement, is equal to an empty set, which is still a null set. So we don't have the complement of the universal set. So that is the property number 2 for complement of sets. So I've written it here. That is to say, the complement of the universal set is a null set. Now let's get to the last part. Now the last one is the complement of an empty set is the universal set under discussion. And this is also true. Now look at this. If you want the complement of an empty set, now the universal set is the one to show complement, and the universal set is there. Now there is no set to be complemented to the universal set. That means that there is an empty set because no members to show or to be compared to the universal set. So if you want the empty set complement, then that is a universal set because it is actually going to be compared to the universal set. So if there is nothing in the empty set, it means that all the members in the universal set is what we call the complement of the empty set or the null set. So this is the meaning. The complement of an empty set is the universal set under discussion. So if you have an empty set, so empty set complement is equal to the universal set. That is what we have to know, because the universal set is supposed to be compared to. So if there's nothing to compare to the universal set, then the universal set is taking control. So an empty set complement is the universal set because there will be no set and still the empty set will not be there. But the universal set will be there. So we are trying to say that the universal set will replace the empty set. So if you want the complement of the empty set, then it should be the universal set. That is a property. So take note of these properties, learn them well as we are going forward in our sets. Thank you.